Now I want to quickly go over the other approach for solution code for the other approach for this problem. So this is the code. So remember what we are trying to do is to look ahead. So for every dry days, we look ahead to find out which lake we should dry. So I need to quickly find out what are the raining days for each lake. So now I will store this information using a map, which map each lake ID to a queue. So queue is a data structure that we have not covered in CP0, but it's conceptually very simple data structure. So it's it supports the main operation it supports are front and pop and push. So you can add things into the queue, and then it has the property called first in first out. So when you add things into the queue, then when you try to take things from the queue, it will take the ones that you added first. So that element is called the front. So you push when you push, it's actually added to the back, and you can take the front, and when you pop, it's the front element that is thrown away. So that's the queue data structure. So essentially, I'm just storing all the days that rain happens over that lake. So this could be implemented using a vector, but then I need to either remember which value I'm looking at, or I need to keep deleting from the head, which will be expensive if this queue gets too long. So yeah, so this is constructed by looping through all the days, and then I simply for each lake I add this day that it rains into this queue. So this queue contains all the days that the lake I. No, this lake got rain, not lake I, and then we have the answer. And the other thing is to store. If I have rain on a particular lake, this lake become full. I want to know what is the next raining day for this lake. So I want to put this information together in a set that is sorted. So then when I encounter dry days, I'm going to find out which is the lake that's already full, but it's going to be rained again the soonest. So that's the lake I want to dry now. So that's the information I store here. So I use a pair. The first one stores the day that the next raining occur, and the next one stores the ID of the lake. So then having that data structure, I just go ahead and for each day, if it doesn't rain, then I need to dry something. I want to dry something. So that I look at this data structure, the next raining day for the lake already full. If it's not empty, then I want to take out the first one. And when I take out the first one, so which will be appointed by this iterator lk.begin, I want to see whether that's day in the past. If that's day in the past, that means too late. I already had the flooding by this time. So then I should return an empty vector. Otherwise, I can diffuse this danger by drying that lake, and then delete this from this next raining day. So for this lake, and if it's already empty, then that means it doesn't really matter. So at this point, it means that at this point I don't have any undried lake, so everything is empty. So then that's okay. So I just assign 1. Okay. So then the other branch of the if statement is the case where it actually rains. So on this day, so for that, I need to add this. Yeah. So for that, what I want to do is I want to add the next raining day for this lake into this data structure, into this set. But then I need to figure out what is the next raining day for this particular lake. So that information is stored in this RD map. So I get the Q corresponding to the RD map, and the first one is that should be actually the current day that I already taken care of. So this is so I throw that away. So the first one is not really the next day. It should be already happened. So after I throw it away, if it's still not empty, then that means I have a next raining day that I need to take care of. So then I will take the front, which will give the next raining day, and this is the lake ID, and then I will add that into this data structure. So at this point, when we exit the loop, that means we have done look ahead for everything, for every day. However, we may or may not have avoided flood. It depends on whether this next raining day is empty or not. If it's not empty, then that means there is a next raining day that we didn't diffuse because we didn't have enough dry days to actually do that. So when that happens, we will return this empty vector. Otherwise, we will return the answer we have constructed. So it turns out that this solution is a little bit slower than the previous one on LeetCode. So again, it depends on the test cases. I think one reason this might be slow is if there is flooding, the other method will detect it earlier. So this one, it maybe you don't detect the flooding when it first occurs. You detect the flooding when you have a dry day and you want to see which one you should diffuse, and then you find out, hey, I'm actually too late, or you actually go to the end. You find out, hey, there was a flooding that I was not able to avoid. Okay.